With trig, you've already seen the first page. The first page of the test is on Edmodo as well. I put it as cover sheet. It gives you some information about the test, and then it gives you the first page of the test, including that you can have a 3x5 card. Just remember the 3x5 card cannot have the unit circle on it, okay? Because the very first question is filling out the unit circle. So you're going to fill out the unit circle, and the next part is going to be questions that look like these. They'll most likely be multiple choice, because then you know if you're doing it correct or not. So the first one should be the easiest, because it's the first thing we did this whole semester. And that is, if I say sine of pi over 4, you're just going to go to your unit circle and find pi over 4, which is hopefully filled in correct right on the page before it. And then you'll say sine is your y value, so it's always that second one. So sine of pi over 4 is the second one. That's square root of 2 over 2. So this is square root of 2 over 2. That's it. That's all we're looking for. Now when we do inverses, if I'm doing the inverse, so cosine inverse of negative square root of 2 over 2, that means I'm going to look for the x value. That's negative square root of 2 over 2. But if you look here, we have a negative square root of 2 over 2 here. And I also have a negative square root of 2 over 2 here. Did I highlight the right? Yeah. I don't want two answers. So that should tell you that we have to remember something about inverses. And with inverses, if I set up a unit circle, let's change this to red. Cosine inverse only exists in quadrant 1 and 2. And the way we remember that is it goes cosine, and sine comes down here. So inverse sine only exists in quadrant 1 and quadrant 4. Alright, so if I ask for cosine inverse, I better pull that number that's in one of these two quadrants. And we look up here, it is the 3 pi over 4, because neither of these exist in quadrant 3, so we don't have to worry about the 5 pi over 4. And all we care about is that 3 pi over 4 one. So I'm going to erase those, and my answer is going to be 3 pi over 4. Here's where we get into some harder stuff. So we have the secant of x equals negative 2. Well, I need to get x by itself because I need to have x equal something. So if I see a problem like this, I'm going to take the secant inverse of both sides, because secant inverse of secant just cancel each other out. They turn to 1. That's what inverses do. And so if I take the secant inverse of both sides, in other words, secant inverse of this side, secant inverse of that side, we're going to be left with x equals secant negative 1 of negative 2. These two look kind of similar. Just remember that secant deals with cosine. Cosine and secant are linked together. When it's the inverse, we need to use cosine inverse. But we need to use cosine inverse of 1 over whatever's in that parenthesis. So maybe I should put that 1, because that's what I added. I added 1 over whatever's in this parenthesis, and now it's okay to do it. Now I'm just looking where is cosine 1 over, or negative 1 over 2. So we look at our x values. These are all positive. So it must be negative 1 over 2 is right here, which is at 2 pi over 3. So this one equals 2 pi over 3. So if I have secant inverse, I'm going to change it to cosine inverse, and I'm going to put 1 over whatever was in here. If I don't have inverse, notice how this is just regular secant pi over 3, not an inverse. To convert it to cosine, we're just going to say this is 1 over cosine of pi over 3. So we go at pi over 3. Pi over 3 is going to be 1/2. So it's going to be 1 over 1/2, which just equals 2. So once again, this is a huge thing that can be easily missed or gotten on the test, is if I'm dealing with inverse, secant, cosecant, cotangent, if I'm dealing with inverses like this, the 1 goes inside the parenthesis. If it's not an inverse, it goes just on top of whatever we had. So this was secant, so it goes 1 over cosine. And that leads us to a cotangent, which is a little weird. When dealing with cotangent inverses, once again I'm going to create a circle to see where both of these exist. And if you remember from your notes, we're going to do the same trick. It goes cotangent. So we have cotangent on top, and we have tangent running down the side. So cosine for inverse, cotangent for cotangent, and tangent. I'm going to do the positive one because this one works out nicely. This one will work just like this one. So I have cotangent inverse of square root of 3. So we're just going to say this is the exact same thing as saying tangent. I want to get out of red. It's the same thing as going tangent of inverse, tangent inverse of 1 over square root of 3. If I multiply the top and bottom by square root of 3, we're going to see this is really the same thing as saying tan inverse of square root of 3 over 3. And square root of 3 over 3, we know tangent is going to exist in these two. So square root of 3 over 3 happens at pi over 6. So this answer is going to be pi over 6. Now this case works out perfectly because if we look at cotangent and tangent, both of them exist in quadrant 1. When I took the tan inverse of square root of 3 over 3, it happened to be in quadrant 1. This is where things turn when we're dealing with cotangent. Cotangent inverse of negative square root of 3, if we follow the same pattern, would be tan inverse of negative 1 over square root of 3. Here's where we run into a problem. This is really negative square root of 3 over 3. But if I go to my unit circle, tan inverse exists in these two. So negative square root of 3 over 3 is here, which would be 11 pi over 6. Here's the problem. Cotangent doesn't exist down here. So does anyone remember how I get from here to the proper quadrant? Yeah? You can just go back like this, so we can say the answer is 5 pi over 6, or you can just add pi also. Either way works. I'm just going to add pi in this example. So I'm going to say because I'm taking the cotangent inverse of a negative, I'm going to add pi to whatever my final answer is. And that's going to equal, like we said, this will be the same thing as tan inverse of square root of 3. Well, negative square root of 3 over 3 plus pi. Negative, bless you, negative square root of 3 over 3 is going to be 11 pi over 6 plus pi. Pi is really 6 pi over 6, so this is realistically 7 pi over 6, which is the exact same thing as 5 pi over 6 if we simplified it, because this is past 2 pi. So this is a full revolution past. Either one of these would be acceptable. Okay? Just remember, if you're taking the cotangent inverse of a negative, you have to add pi. Okay, that's a real quick rundown of all the most complicated ones, but if you could do all of these, you can do any one I give you. Bearing in mind that you realize that cosecant actually deals with sine. And you have this down, you have the first section of the test done. Because if you know the unit circle, these are the first few 6, 7 questions on the test. All right, so you already know what's gonna look like for the first section. I don't care. No, yeah.
Is this going to be on Edmodo too, this practice?
The practice exam is on Edmodo, and so is the solution key, and I'm recording video right now, so the video will be on there too if you missed class, but you're all here. Okay, the next section I'll talk about is trig functions, graphing them. Big thing to know is make sure you absolutely know the big guys. All right, so if you're completely out of time, know your sine, your cosine, your tangent. If you have a little additional time, make sure you know how to do your cosecants, your secants, and your cotangents. Don't spend a bunch of time with the inverses. All right? These graphs, I'm not going to ask you to graph the inverses. So right off the bat, you don't have to know those. You should know them, but I'm not going to test you on them.
Yeah.
Woo! Okay, no matter what it is, whether it's an inverse, whether it's sine, cosine, tangent, or whatever, we can always break it down into something that looks like this, where we have A, B, C, D, no matter if it's tangent, cosine, and they all do the exact same thing. That D, way at the very end, that controls my up. It will move a graph up, or it'll move it down. This C here, that C there is going to go left. And right. It's going to go left if it's positive. It's going to go right if it's negative. I should also note that these are shifts. All right, so if I have a positive 3, it's going to go left 3. If it's a negative 3, it's going to go right 3. That B right there, that B right there is going to control my period. And right below that, make sure you write that the period is actually 2 pi divided by B. That's why when our B is 1, our normal period is just 2 pi. Normally it's just 2 pi if I didn't change anything. All right, the last thing is our A value, and that is our amplitude. Just remember, too, the amplitude can also flip it. If it's a negative amplitude, it means instead of going up for sine, it's going to go down. It'll flip everything across. All right, this is about as hard as I can make a graph of these. All right, it has everything on it. It has a shift up, it's got a shift left or right, it has a change of period, and it's got an amplitude change. Before I figure out what's going on, I'm going to recognize that this B value has to be outside of parentheses. It can't be attached to the X. So if I have a number in front of here, and it's in parentheses, we have to pull out that 3 outside. So the very first step is to pull that 3 outside so it's in the B form. But since I would need to distribute a 3 back in, that 3 has to be pulled out of this negative pi as well. So that's going to give me y equals 2 times sine of, I'm pulling out a 3. 3 times x, we're good there. And we're going to have minus pi over 3 plus 1. And just to check to make sure I did everything right, 3 times x is 3x. 3 times pi over 3 is going to get me pi back out. You have to do that in order to know what your period is and what your shifting is. Okay? Because right now it looks like I'd be shifting it right pi units, but it's actually right pi over 3 units. All right, so if you have a number in front of this x, you have to pull it out front. Okay, so all the information we have is right there. It is going to go up 1. It's going to go right pi over 3. The period is going to be 2 pi over 3, and our amplitude is 2. So that's a ton of information right there. Just telling me that you know this stuff pretty much gets you most of your points. All right, how you're going to graph this is you're going to graph your period first. This is always your starting off point. And whatever value this is, if this was a 1, it would just be 2 pi, but since it's 2 pi over 3, I'm going to count out 4. I'm going to go 1, 2, 3, 4, and I'm going to put 2 pi over 3 right there. So 1, 2, 3, 4, and I'm going to put 2 pi over 3 right there. I'm also going to label my y-axis. I'll label as 1, 2, 3, and down here I'll label as -1, -2, -3. All right, I do have to label these inside points. All right, in order to do that, I'm going to do that half multiply by 3 trick I did before. So we are going to multiply this by 1/2 to get here. So from here to here, we're taking a half of it. In other words, we're multiplying by 1/2. Well, if I multiply by 1/2, I'm going to have 2 pi over 6, which is really just pi over 3. Then I'm going to multiply by half again, multiply by 1/2 again, which is going to give me pi over 6 here. And the very last thing we're going to do, let me change my color because I'm going the other direction, I'm going to multiply by 3. So this is multiply by 3, which would be 3 pi over 6, which is actually pi over 2. And now I have all the major points labeled. Half, half, multiply by 3. Easiest way to do it. You can figure it out other ways, but this is just the easiest, no nonsense, just get to the answer. All right, I'm going to graph this with the amplitude first. So I'm going to graph it in 2 steps. First step is I'm going to graph it with the amplitude being 2. So a sine curve with amplitude 2 is going to start at 0, 0. At pi over 6 is going to be at 2. Back down to 0, down to -2, up to 2. So this is my first step. So that is just taking into account the amplitude and the period. Well, once I get rid of the amplitude and the period, I just have right and up. So every one of these points has to be shifted right, pi over 3. So if you look at this first one, I shift it pi over 3, and I raise it up 1. So my actual point is going to be right there. Once again, I shift it over pi over 3, up 1, so it'll be right here. Yes?
Does it matter if you do horizontal or vertical translations first? Does it just matter that you do the amplitude first?
Do the amplitude first.
Okay.
Yeah. With sine and cosine, it really doesn't matter what order you do the stuff in, as long as you do it correctly. Because if I did amplitude last, just make sure you stretch it properly, that your next point is 2 away. Okay, I generally do my amplitude first, so then I don't have to worry about it. Now I just got to move the points left and right. I don't have to worry about pulling or stretching. All right, for my next one, I move over 2, up 1, so we're over there. Next point, over 2, up 1. Over 2, I'm going to go down 1. Ooh. Over 2, up 1. Over 2, up 1. And that is going to be my final graph. That is one period. All the translations happened. Left, right, up, down, pretty easy. That's why I always do my amplitude and my period first. So plot your period, do your amplitude, and then just go left, right, up, down. Good? Makes sense?
Yes.
All right, solve the right triangle where A equals 60 degrees and C equals 20, and C is also the hypotenuse. So we have a right triangle. I'm not going to go through this whole thing. It's just a setup. So this must be C because it says that C equals, side C equals 20. I got my A up here, which means I have lowercase a here. I got B here, which means I got lowercase b here. C equals 60 degrees. B equals 30 degrees. If you're really sly, you're going to realize that the 60, 30, 90 degree triangle. I'm not expecting you to do that, but if you did realize that it was 60, 30, 90, the one across from C, or the right angle, maybe I should make that a right angle, that's your 2s, where this would be our s, this would be 10, and this would be 10 square root of 3. I'm not asking you to do that, so I'm not going over how I did that. I'm going over the fact that since I know that A is 60 degrees, I can say the sine of 60 degrees equals opposite over hypotenuse, so A over 20. So in fact, side A is just 20 times sine of 60 degrees. And then you can figure that. I'm not actually going to go through everything. But you can do the same thing with sine of B. I just want to recall that this could be on this final, right? This is something that's easily overlooked, but should be a really easy problem. But you'd also solve for B. I'm not doing that. That is on the sheet, but I'm not doing it right now. Make sure you know these. This will not be on the test. This will not be provided to you. Once again, what will be provided to you are all of these. All of these will be on the test. I put below will be provided on the test. These guys will not be on the test, and it is needed that we know these. So the first one says, given that tangent alpha equals -2/3 and alpha is in quadrant 4, I'm going to note right away that quadrant 4 tells me that my sine value, all students take calculus, sine is going to be negative and cosine is going to be positive. Alright, I need to get from tangent to either cosine or sine. Because remember, sine squared plus cosine squared equals 1. So as soon as I know sine or I know cosine, it's just that matter to get to the other one. So we need to get from tangent to either sine or cosine. And without doing a whole bunch of thinking, I'm going to look at this guy. Although it says secant, secant should scream to you, hey, cosine. Secant can lead to cosine really easily, so this is tangent to cosine. Right here is the 1 plus tangent squared secant squared. So this guy right here is going to be my key to get from tangent to cosine. So we're going to use that here. So we're going to say 1 plus tangent squared, well our tangent is -2/3 squared. That's going to go ahead and that's going to equal our secant squared. Let's just call it alpha. Alright, then minus some work, we're going to come up to the fact that 1 plus -2/3 squared is going to equal 13/9, which is going to equal secant squared alpha. But I would need to take the square root of both sides. So in fact we have 13, or square root of 13/3 is going to equal secant. I don't really care what secant is, but it was my gateway to get to cosine. So we're just going to say that cosine of alpha is going to equal 1/secant of alpha, which is just going to be 1 over that square root of 13/3, which equals 3 over square root of 13. Then I'm going to note that because cosine's positive, this one should also be positive. Alright, so that's how you get cosine. Now to get sine, we're just going to notice that sine squared plus cosine squared is going to equal 1. So we could say that sine squared plus 3 over square root of 13 squared equals 1. And we're going to solve for sine squared just like we did secant squared. Okay, and all those steps are on there if you get stuck. That is where I'm going to end. So I'm going to let the rest of the time is for you to work on whatever you need to. Notice that my next one is rewriting something. We will have to know how to rewrite something in other terms. So this says not in fractional form. Why I picked this one is because you actually have to multiply by the conjugate on bottom and top. Don't forget about how to do that. So this one would just start off with multiplying the bottom by 1 plus sine and the top by 1 plus sine.